Okay, in section 14.4, we'll be talking mostly about simple machines. The simplest machine is a lever. A lever simply is a bar or a rod that is used to give a mechanical advantage. You'll see that three main components are required for every type of lever. You have an output force, an input force, and a fulcrum. The next thing that's important to understand about levers is that the mechanical advantage of a lever is found by taking the input arm and dividing that by the distance of the output arm. So, if we use that example with our simple lever here, what we would find is, let's use this information in this example. Let's pretend that our input arm is 20 centimeters long and that our output arm is 2 centimeters long. So 20 divided by 2 equals 10. This means that the mechanical advantage of this lever here is 10. This first lever is an example of a first-class lever. That means that a first-class lever can have a mechanical advantage greater than 1, equal to 1, or less than 1, depending on the position of the fulcrum. If the fulcrum were to be exactly in the middle, that would mean you would have 10 divided by 10, which would equal an exact mechanical advantage of 1. If, however, for example, the fulcrum were closer to the input force, as it would be imagined here, that would mean that the distance here would only be 5 and that the output arm would actually be 15. This would result in a mechanical advantage of less than 1, which would make Now let's take a look at a second-class lever. A wheelbarrow is an excellent example of a second-class lever. Notice that in a second-class lever, your output force is between the fulcrum and the input force. A second-class lever always has a mechanical advantage greater than 1. An example of a third-class lever is a broom. Notice that a third-class lever is essentially the exact opposite of a second-class lever like a wheelbarrow. Notice that in a wheelbarrow, the output force or the load of the wheelbarrow is in the middle and the input force is at the handle. It is reversed in a broom. In a broom, the output force is on the outside and the input force is on the inside. Output force, input force, fulcrum. Because of this, the mechanical advantage of a third-class lever is always less than 1. The next simple machine that we'll be looking at is the wheel and axle. The wheel and axle is very common. Perhaps the most common is a screwdriver. Also very common and mentioned in the book is a steering wheel. The important thing to understand with the wheel and axle is how to find a mechanical advantage. And that's done simply enough using this formula. You can take either the radius or the complete diameter of the input force and divide that by the output force. So that means the thicker the handle of the screwdriver, the more efficient or the more easy it will be to turn a screw. If you have a screwdriver that has a very thin handle, that means it will be much more difficult to turn a screw. Let's imagine that the complete diameter of this screwdriver is 3 centimeters and that the output diameter is 0.5 centimeters. So that means the mechanical advantage of this particular wheel and axle is 3 divided by 0.5. This gives us a mechanical advantage of 6. The next simple machine is an inclined plane. Remember, an inclined plane simply is a ramp. Now, it's important to remember that the mechanical advantage of an inclined plane is the distance of the plane divided by the height of the plane. Distance of the plane divided by the height of the plane. Now let's take a second and compare the mechanical advantage of these two planes. Okay, let's do the math. 20 over 10 equals 2. That means the mechanical advantage of plane A is 2. For plane B, we do the same math, 30 over 5. We see that the mechanical advantage for this plane is actually 6, which has the greater mechanical advantage. Clearly, inclined plane B has a higher mechanical advantage. That means moving an object up inclined plane B would be much easier than up plane A. You should know this intuitively because this is steeper, and so it would be more difficult to walk up this plane than this plane, which is less steep. Let's look at two more examples of inclined plane. In reality, a wedge is, in fact, inclined planes. Two inclined planes, one on each side, which increase your input force, showing here. Lastly, a screw is actually an inclined plane wrapped around a cylinder. What that means is the same thing, that the closer that these threads are, the more mechanical advantage there will be. Just as if I have an inclined plane that looks like this, it will have a greater mechanical advantage than an inclined plane that looks like this. Okay, the last simple machine we're going to look at is a pulley. The first pulley that we look at here, you'll notice that it's simply a change of direction, and that my input force is exactly the same as my output force. This next pulley, you'll notice, is different because the pulley itself can actually move freely on this cord. What this does is it actually takes my force and divides it in two, making it much easier to lift something. Finally, let's look at this more complicated pulley system. This pulley system combines several different types of pulleys. What it does is with each additional pulley, it divides my force. That means my force of 4 is divided equally between each of these pulleys. 1, 1, and 1, making it much easier to pull. You actually only have to pull with a force of 1 Newton in order to lift a 4 Newton mass from the ground.